And then we print it out and have a look, and we should see this. And look at the outcome of the toString function. It really converts the data frame into a text. So it's actually a string, but it is formatted nicely with new lines and spacing out nicely, even right justifying the numbers nicely, so as to give a very decent columnar kind of textual output. Yeah. And the last thing to finish this up, as far as storage is concerned, because up to here, before the file name, we are still operating within the Python's memory. So if we have a sudden power off, everything is gone. So we need to write it out to the hard disk. If hard disk sounds foreign to you, think of it as USB thumb drive, right? So store it in thumb drive and then it becomes permanent, even across power cycling. So we can shut down and next day we boot it up again, just read it back from the hard disk. Yeah. So this is the magic here. We are using the with open. All right, we open up a file handle and then using the file handle to write to this file name, which is dfout dot text. We supply the text out text here, and that's it. So within this line, once this line is done, that's it. We can go and check our Windows Explorer or Max Finder and see that the df-out.txt is written out in the same directory as your as this particular piece of program. Okay, so here, not really a proof, but at least seeing that the icon there is shown in my Windows Explorer is nice. And then when I open it using Notepad, we can see that the content is indeed the same as what we see in the memory. And don't forget, this opening up using the Notepad is opening up the file from the thumb drive. Next thing I want to point out to you, in case you haven't kind of detected it, Notepad is a totally separate application run asynchronously. That means it is run at a different time from your Python's execution. So you're running Python now, you finish running, you power off. Next day, 1 week later, 1 month later, you power up again and run, open up this df-out.txt using another application because your Python program is corrupted. No problem. The content is readable by another application. One more thing, you unplug your thumb drive, pass it to your friend, maybe mail it to your friend thousands of miles away, and he can open it up using his text file editor. It doesn't have to be Notepad. Like MS Word can read text file as well, and you can see exactly the same image. Really, really powerful communication resulting from the ability to output the data frame permanently into storage. Okay, very, very amazing step over there. I'm not sure if you have sensed that, but that's definitely very amazing. Okay, so if we can write out, we ought to be able to read back in the text file. So the text file handling, when we write out, we first generate the text string, then we use the, you know, inherent function open and then file handle dot write, right? So we use that to write it out. Reading back is way easier. Okay, so reading back is very simple. What we do is just use PD, not DF, PD dot read underscore table. So it is not read underscore text, but read underscore table. So table will just be any text file that contains a kind of a table-like layout. Okay, so we use space here, but read table is pretty powerful. You can actually also have a comma or semicolon or whatnot. And for now, we just try to read back our df out. But there's one twist that I want to sort of convince you that it is not a pre-orchestrated kind of reading. Oh, actually, it's already there, you know, but I just show you this. No, you can do it yourself. What you do is you make a copy of df out, rename it as dfout2.txt, so it's a different file, okay? And then you hand type in using Notepad or file editor, or if on Mac, I don't know, some form of text editor, open the df dash out to.txt and then manually type in uh, 3 new entries. All right, I happen to just type cas space, and you see that I'm not even following the exact layout. I put some spaces in front of Lars, and there are only 2 spaces before I put in the age, but there are 3 spaces between cas and 25 here. So yeah, and I hand typed in false. Right, I hand typed in false and true here. So there are 3 new entries. My hand manually typed in entries. Now, what can happen in real life is that this file is being updated by your customer, completed by your colleague, or else with additional updates by some temporary staff or whoever to help to expand the data set here. All right. So DF2 is new updates, the old records appended with new updates. Then the question is, oh, can we read back in and process with the new numbers, with the new ages, with the new credits, and so on? Can. Yes, we can. By just running pd.read_table. Okay, as simple as that. One liner, that's it. We get the data frame. Now, the question is, remember, when you are outputting, sending out to the hard disk, you need to start with the data frame that you are interested in outputting, correct? So it's quite clear. But when you're reading back in and therefore creating a new data frame, then it's a bit like pd.dataframe. You're creating a new data frame, except the data is accessed or read in from elsewhere, not from the listed data in the Python script. Okay, so that's why we have pd dot. So it's quite consistent. Now let's look at the details. Read_table from the file name, right? From df-out2.txt from the file name. And here are 2 additional named parameters that I want to always fill in just so that the default values are clear. If our file has a header like name, age, credit, drives, right? Some text files don't come with the header line. It's understood, and so you need to subsequently update the dot columns of the data frame created yourself. But here in our experiment here, it does come with the column name. So we want Python to be able to read these names in and automatically create the columns named after them. We don't want to have to, scan everything again and, patch it up and all this. So we say read table, please look at the first line, and first line is position 0. So 0 here doesn't mean there is no header. It means header is located at line 0. Remember, it's 0 base. So line 0, please read this line 0. You're telling the read table function and interpret it as the column names. So don't put in as data. But thereafter, read in each line as a separate record, as a separate row, where the columns, all right, are delimited by white space. Delim white space is true. So it's trying to say, understand any white space, single space, multiple spaces, like this rubber band kind of counts of spaces, and even tab, because tab is invisible on the screen as if they were spaces, right? Treat all these long and short spaces as just a separation of 2-column data. Don't be so sensitive to them. So long spaces still means one separation, right? So when you set it to true, it's very flexible, and we like that. So then we print it out, and we will see inside memory this very nice familiar data frame. It's almost as if it's magic. It's like even though it's someone else who updated this data for us, now it's like mine. And we can just process it using the same logic. If you're doing average of all the ages, do a dot mean. It's the same. And then we check the types and all. Okay, so in memory, it will look like this, which is exactly our intention. We have successfully read in the text file. Next, let's take a look at another very major category of file type, and that's called comma-separated file. Comma-separated value file, or CSV. So comma-separated value file, when we need to write to it, yes, by now it's quite clear. and it's becoming more symmetrical. Right to it, we say that data frame to CSV, to underscore CSV, right? And if you want to read back, PD, because we're creating a new data frame, dot read CSV. So write means to, read back means read CSV. Very simple. It's symmetrical, right? So the same data frame, we can even output to several different file formats for everyone's convenience. And that's as simple as just changing the function name. So let's start again with the same sample database, our 3-row, 3-member database. And then we make some assurances of the data types. Yeah. Then we have this. Okay. Now we try to save it. We try to save it into this file, dfout.csv. Simple as that. Df, the intended data frame, dot to CSV, the file name, and minimally, I would just put in index equals to false. That means we don't want to see this 0, 1, 2 being stored in the CSV file. And as it turns out, that index values, they're all gone. But if you don't do anything, all right, that means you just put in the minimum requirement file name, you will see additional column, the initial column, column A, being 0, 1, 2. Now that is good if you know what you're doing, you write it out temporarily, and later on in your program, you read it back in. That would be okay because you know that it's there and you're reading back in, it's fully preserved. So that's really nice. But of course, if you're exchanging information with other um, servers or users or colleagues or suppliers and customers, then you may not want to confuse them because the dot index might not make sense to them. It's not kind of formal data, you know, it's not the actual data that you want to exchange with people. It's a pseudo data that makes sense for computation. All right. And then when you want to read back in, you're creating a new data frame from this CSV data. So very simple, pd.read from the file name. That's it. That's it. Simple as that. Okay. Totally no issue at all. And there is also a dot index, a comma index equals, but by default, it's not assuming any index there. So you just read it in, it will work. So the default index values is simply just a range. So if you have if you have 4 rows, then you'll be range 4, so 0, 1, 2, 3. Now again here, just to test that pandas actually is reading in the file, we open up using Excel. Excel can read CSV file, and just type in one more row. So we add in one more entry. You can type in new. I typed in new B, right? Something like that. And we change Seth. All right, Seth originally credit score was negative 150. We changed to 123.45. And when we read in, it is correctly updated. So we're actually getting the updates from our manual entry using a different application, whether it's Excel or Notepad or other text editor. Yeah, it's doable. Okay, so this is the amazing part. Permanent storage, editable by other applications on the file. And this file, of course, is isolated, so you can send it through email attachment, USB drive, post it to Dropbox, share it with people in the cloud, and so on. Now, of course, with proper justification, you don't try to share other people's data.